Hi, everybody. My name is Paul Zhao, and I'm the product manager for Amazon Transcribe. I want to thank you for joining us today in the session called Transforming Healthcare with AI. So before I begin, I'd really like to talk about the AWS AI ML stack for a little bit to kind of help us get our bearings. The AWS AI ML stack starts with really 3 layers, and at the first layer are all of your ML frameworks. So here you'll see things like TensorFlow, MXNet, PyTorch, what have you. And at AWS, we don't have any bias for any one particular one. We don't advance just any particular framework. We treat them all relatively equally, and really we focus on enabling all of them. At the next layer are your ML services, so that might include something like Amazon SageMaker or even AWS DeepLens, which I'm sure many of you have already had a chance to play with at last year's reInvent and test out. And then at the highest layer are what we call the AI services. Here we have 2 big groupings, one for vision and another for language services. So within vision, you might have something like Amazon Recognition for image recognition or Amazon Recognition video, which, true to its name, will recognize entities within videos. And then in the language group, you're going to have services like Amazon Poly, Amazon Transcribe, Translate, Lex, Comprehend, and even Comprehend Medical. And all of these services are really, really easy to use APIs that help to add special capabilities to your applications. What I really want to focus on talking about for now is Amazon Transcribe. And again, you can see here, Amazon Transcribe lives at this top layer within the AI language services group. So Amazon Transcribe was actually launched almost 2 years ago, and I'll give a quick refresher. The service is an automatic speech recognition service, long for ASR. The whole purpose of it is to make it super easy for developers to add general speech-to-text capabilities to your applications. So Amazon Transcribe is available in 2 modes. We have the batch service, and we also have the streaming service, or the real-time service. In the batch world, we support 31 languages today, and we support popular formats such as WAV, MP3, FLAC, and MP4. We offer a slew of helpful and interesting features such as custom vocabulary. And the way that you use custom vocabulary, for instance, is to upload a list of terms that would otherwise not be normally part of our recognition lexicon. And so using that list of terms helps us to augment the ability to recognize those terms in the final transcript. We also offer automatic punctuation and capitalization, and as true to the name, what it means is that you no longer need to explicitly call out things like comma, exclamation mark, or capitalization of certain words. Instead, it's all handled automatically out of the box. The service also offers word-level timestamps, which means for every single term that is output into the transcript, there is a beginning and an end timestamp. And this is a really, really useful feature, especially if you have a use case like doing subtitling, in which case you'd like to have traceability to map that transcript back to different parts of your video, for instance. The service also provides word-level confidence scores, which means it provides a percentage confidence on how well we think we've done transcribing each term or recognizing each word. And this follows in the mantra of being very transparent and offering you, the user, the flexibility to determine for yourself whether you'd like to set certain thresholds to expose or drop certain terms with associated confidence scores. There's another feature called channel identification. Channel identification does basically what it sounds like. It identifies each channel in a multi-channel audio file, for instance, and then it's able to run the transcriptions of each channel's audio separately. And this can come in very handily if you had, say, 1 speaker per channel, because now you can run each channel transcription separately and get very, very highly accurate speaker-associated transcriptions. And then the output would actually show in the JSON the channel 1 or channel 2 outputs, so that you know which speaker is saying what at what time. Finally, we offer speaker diarization, which is the ability to separate out speakers. So in this case, you might want to use the feature for when you have a single audio or a mono-channel audio, right, where multiple speakers are being recorded on that single channel. With speaker diarization turned on, you can essentially identify who speaker A or who speaker B and so forth are. In the streaming side of the world, we support 6 languages. We also support linear PCM. And as you can see, custom vocabulary, automatic punctuation, word level timestamps, and word level confidence scores basically mirror what already exists in the batch world. But because the streaming service is a real-time service, it operates over HTTP2 protocol and also WebSocket. SDK support is available in programmatic languages such as Java, Ruby, and C++. We have quite a slew of heavy-hitting customers who themselves have used us for a variety of use cases, as I've mentioned earlier. GE Appliances, Echo 360. Echo 360, for instance, is an educational platform that uses Amazon Transcribe to transcribe a diverse range of educational content, be they lectures, seminars, presentations across, again, a very, very diverse range of topics and subject matters as well, from science to social studies, or even to more of the vocational training assets. But here's the thing about Amazon Transcribe is that as a general transcription service or general speech recognition technology, Amazon Transcribe was not really meeting the needs of transcribing medical speech. And that's primarily due to the sophistication of technical jargon in the healthcare and life sciences domains. So the problem that we really want to speak to here is that there's a tremendous amount of audio data generated each year. In fact, there's approximately 1.5 billion hours of medical audio that's generated per year. And there are tremendously valuable insights and data that are trapped inside all of this audio. And what's really incredible is that there's even more billions of hours of medical audio backlog that already exists. And finally, more than 90% of this audio is actually generated by clinicians each year. So being able to extract all that information out from that audio is absolutely key to enabling our customers to be able to divine better insights, and ultimately for clinicians or pharmaceutical companies to provide for better patient care. So we believe there's a better way to get it out, and we've introduced this new service called Amazon Transcribe Medical. Again, going back to that stack page, we can see that it sits at that top layer right next to Amazon Transcribe. Again, it's supposed to be a very, very easy to use API to help with medical speech to text. So Amazon Transcribe Medical is an automatic speech recognition service that makes it easy for developers to add medical speech to text capabilities to their applications. So Amazon Transcribe Medical can be really captured in 3 big pieces of focus, right? First is accurate. The second thing to mention is that it is very, very easy to use. And the third thing to mention is that it is very, very affordable. So let's go ahead and unpack each one of these areas. In terms of accuracy, Transcribe Medical supports transcription of medical speech in US English today. We also support coverage of primary care, meaning we can transcribe specialty language for for internal medicine, for family medicine, for pediatrics, and OBGYN. We support transcription of not only dictation, meaning physician dictated notes, for instance, after a patient encounter, but we also cover transcription of conversations, meaning if a patient or a clinician are having a conversation in real time, we can transcribe that conversation on the fly. In terms of ease of use, Transcribe Medical is made to be real time, meaning that in the moment that you pass the audio through, you will be getting a commensurate amount of text output as well in return. It's designed to transcribe natural speech, meaning there's no more need to explicitly call out punctuation or capitalization. Instead, you can just speak naturally, and the system is intelligent enough to automatically punctuate and capitalize going forward. The service, just like its general ASR counterpart, offers word-level timestamps, again, to help with that traceability. And also it offers word-level confidence scores, again, to offer transparency and showing you how well we're performing in terms of showcasing the correct recognition of terms. And finally, in terms of affordability, Transcribe Medical is a pay-as-you-go model. It uses a pay-as-you-go model, meaning that there's no lock-ins. It's very, very flexible, and you have that convenience to terminate usage or to pick up usage anytime you want. Separately, we also charge by transcription usage. And this is a huge advantage because it means there's no such thing as license fees or per seat fees. There's no such thing as implementation fees. It's very straightforward. We charge 7.5 cents per minute, and there's a 60-minute free tier for all new signups per month for the first year. I want to dig a little bit deeper on how easy it is to use Amazon Transcribe Medical. If you have a microphone-enabled client on the front end, it's as simple as calling the API to establish a secure WebSocket connection. It's a bilateral connection over which you can begin to pass an audio stream to our service, and then in return, the service will return a text stream in the form of JSON blobs. Amazon Transcribe Medical is HIPAA eligible, which means that the service neither stores inbound audio nor does it store the outbound or output transcripts. I'd like to talk a little bit about the Transcribe Medical use cases. There's clinical documentation. In clinical documentation, virtual scribes, for instance, can be built on top of Transcribe Medical to capture both clinician-patient conversations or even single-speaker medical dictations. In pharmacovigilance, key phone calls from patients and clinicians about medicinal effects can be accurately transcribed for pattern detection. So that's used for drug safety monitoring. In telemedicine, Transcribe Medical can be leveraged to generate subtitles for clinician-patient engagements, especially for those patients who may be hearing impaired and are connecting with clinicians on a remote basis through telemedicine. And then finally, healthcare providers and insurance payers can transcribe contact center calls and use transcripts in real time to drive agent coaching and even trigger downstream actions. Before going further, I'd like to take a quick moment to also revisit Amazon Comprehend Medical, right? Amazon Comprehend Medical is a HIPAA eligible service that uses machine learning to extract medical information with very, very high accuracy with the purpose of reducing cost, time, and the effort involved in processing large amounts of unstructured medical text. Comprehend Medical is a natural language processing service that can detect key medical entities such as medications, medical conditions, anatomy, even tests and procedures, or perhaps even protected health information, otherwise known as PHI. Moreover, it can extract relationships between entities, for instance, the name of a medication and the dosage that is administered or prescribed, or even determine the relationship of an anatomy, such as a limb, and then determine the directional value of it, meaning is it the left arm or is it the right arm? So now what I'd like to do is actually talk about how these two services, Transcribe Medical and Comprehend Medical, work in conjunction with one another. I'll illustrate an example using one use case, which is in clinical documentation. So before showing you the example, I'd like to talk about what is the problem that we're helping customers solve here in this space. And that is that physicians today are spending anywhere as much as 62% of their time on just clinical documentation alone, right? That means the remaining of the time is solely used for patient care and patient focus. And this is really not a great use of physicians' time. Not only is that the case, but also it's a huge contributor to physician burnout as well. So there's a lot of ongoing effort with customers who want to build things like virtual scribes or voice scribes that capture the engagements of physicians and clinicians as it's happening, so that clinicians can really focus on giving patient care rather than having to play a secondary role of being a clerical scribe, for instance. So let's take a look at how we string together some of the services that I mentioned earlier, Transcribe Medical and Comprehend Medical, to enable customers who want to build something like a virtual scribe. So here in the clinical documentation use case, Imagine as a physician, right, that I'm trying to take progress notes, which is being recorded using an application that, for instance, has a web browser or mobile app experience. And that audio is collected by the on-device microphone and is sent streaming to Amazon Transcribe Medical. As you recall, Transcribe Medical is going to send the speech recognition results back with partial hypotheses as and when they become available. I have a front end that is collecting this audio, passing it along to Transcribe, and then in a separate loop working with the WebSocket, it is waiting on results from Transcribe. When those results are at the right level, you're saving them off in partial chunks in DynamoDB or some kind of temporary storage. And then you're also saving them off to S3 or some kind of permanent storage. After that, after all, if you've paid for the transcription, you might as well hang on to it. Now, when that transcript becomes available, you want to annotate it using Transcribe Medical because, for instance, you'd like to discover if there are anatomical references or PHI references, etc. So what you get back from Comprehend Medical is a list of entities along with where they occurred in the medical note. And that way you've got this augmented clinical note that you can then save off as an update to the EHR. So in terms of the overall flow, we're starting off with some kind of client device. Then we see that the audio stream goes to Transcribe Medical. Those partial results are stored in a temporary storage. Final storage for the transcripts will become available. And then along with the augmented data so that you can make it all part of that clinical record. And finally, the updated data is what makes its way into the EHR at the very end. I'd like to illustrate another example using a use case. In this case, I'll use drug safety or pharmacovigilance. So pharmacovigilance is the science of collecting, detecting, monitoring, and preventing adverse effects with medicinal products. One of the primary means of collecting this data is actually through clinician and patient phone calls who directly report on medicines and their effects. The goal of pharmacovigilance is to enable people to use medicine safely. And we're not going to get into the entire workflow here. The presumption is that you have some form of workflow already existing. And in our use case, we're going to assume that we are working with recorded audio, such as phone calls. And that audio is made available by a service like Amazon Connect, for instance. The point is that this audio makes its way to Amazon Transcribe Medical, whether that be streaming or in batch mode. The results of that transcription are then saved in Amazon S3. The text can then be run through Amazon Comprehend Medical to look for specific drug references or conditions that were discussed. For instance, if a particular medicine seemed to have an incidence of nausea, you'd expect Comprehend Medical to surface that information for you. And that augmented text, along with the original transcript, is then made available in long-term storage like S3, where you can query it ad hoc using a serverless query service like Athena, or for example, in data warehousing storage like Redshift, where you can then make structured queries on it. At the end of the day, you want to make this data available for trend visualization, monitoring, or even alerting so that it can be incorporated into the rest of your overall workflow. I'd like to show you how Amazon Transcribe Medical works and where you can go to get started. So I'm just going to flash over to my browser here. So this is the console for Amazon Transcribe Medical. You can see that it's a real-time transcription service. And what I'm going to do is run through a quick demo. I'm going to start a stream. And before I do that, I can choose either whether I want to transcribe a conversational speech or whether I want to transcribe dictation. Since I'm the only one here, I'm going to choose dictation and pretend that I'm a physician and dictate some medical notes. I'm going to go ahead and click Start Streaming. Patient is a 60-year-old male who came into the hospital concerned about heart arrhythmia. His diet is normal and his blood pressure is 120/80. Okay. Now I'm going to click Stop, and then you can see very straightforward, right? Patient is 60-year-old male who came into the hospital concerned about heart arrhythmia. His diet is normal and his blood pressure is 120/80. So here we've demonstrated how you can just easily access the AWS console, the service console for Transcribe Medical, start a transcription stream, select whichever mode that is going to meet your use case, and then begin speaking into a microphone. In this case, I'm just using my laptop, and the service will be able to output the corresponding medical text in real time. Something to call out is that Transcribe Medical, because it's geared towards the medical use case for the healthcare and life sciences domain, it's able to capture sophisticated technical jargon like heart arrhythmia. It's also able to normalize key quantities like 120/80 to help physicians or whoever else may be the end user quickly and easily recognize those quantities for charting or documentation purposes. So Amazon Transcribe Medical is actually available across 6 regions today. And I'd like to show you a broader demo at this point that showcases how Transcribe Medical and Comprehend Medical can be built to really deliver an awesome experience. So let's take a quick look at that. So what we've got here is a quick and dirty demo. It's nothing too fancy, but the whole purpose of this is to show you how these 2 building blocks, one which is a medical ASR service and another one which is a medical NLP service, can be strung together to work in conjunction to really unlock those insights and valuable pieces of information within medical audio that's either recorded or being recorded on the fly. So I'm going to play a pre-recorded dictation that I had done beforehand and just start dictating that into the system and show you how it works.
This 55-year-old man with known coronary artery disease comes for a follow-up visit today. Last month, he was admitted to our hospital with unstable angina. He underwent heart catheterization on November 15th, 2007. At that time, he was found to have a tight 99% proximal stenosis, total occlusion and collateralization of the mid-circumflex. Right coronary artery was normal. Ventriculography was normal and his ejection fraction was 65%. He underwent an uncomplicated placement of a ciphered drug-eluting stent to his proximal lesion. The attempted coronary intervention of the circumflex was unsuccessful, as his lesion cannot be crossed. His post-procedure was uncomplicated, and he was discharged on the day following his intervention. He comes today indicating that he is feeling great. His current medications include aspirin, 325 milligrams daily, Lipitor, 40 milligrams daily, and Plavix, 75 milligrams daily.
Okay, so what you just saw there was Amazon Transcribe Medical, showcasing what it can do. You can see that we've built a pretty straightforward front end whereby we're actually leveraging the timestamp information that's already embedded in the transcript in the backend and using that to inform where we are in the transcription process, right? You may or may not want to do this, but in this case, we're just showing you that this is one way to leverage the timestamp information that comes right out of the box as part of the transcripts. Something that's very interesting here is that by pumping all of these accurate transcripts into the next service, Amazon Comprehend Medical, we're able to then begin to dig into these insights that were previously not available to us in audio form. So if we wanted to, for instance, detect all protected health information, I can go ahead and call the API to be able to recognize those terms. So in this case, the example is a 55-year-old man, so age is a protected health information. And also sometimes dates can be protected health information as well. If I'm interested, I can also look into medical conditions. I can also highlight anatomies, or in this case, underscore with red squiggle, and also underscore medications that were discussed in this particular note. I can also then outline tests, treatments, and procedures. But in addition to doing these things, which is a lot of annotation, what I can also do is click into any of these entities. For example, I can click into ejection fraction. And what you'll see in the right-hand panel is that we're using the Comprehend Medical API to reveal the relationship between the entities. So you see the ejection fraction falls under tests, treatment, and procedures. And then it's associated with the quantity 65, which has a percentile attached as the unit of measure. And this actually can be very, very useful for a variety of purposes. So if we talk about the use case involving clinical documentation, you can see how this quickly helps physicians get to really the heart of the matter with all of these types of entities and key terms. We can also show an entire summary here by clicking on this little button that we built, and basically easily and visually display out all of the entities, the types, the associated confidence, and any attributes and traits where available and appropriate. Taking one step back, you might recall that I talked about confidence scoring from Amazon Transcribe Medical. If I really wanted to, what I can do is set certain thresholds and say, you know what, let me go ahead and hide the summary first, and say, you know what, I'm actually only interested in terms that have been transcribed with, say, 90% accuracy, right? And so in this case, what I've done is said, I'm going to highlight any sort of low confidence terms. And what you can see is that the word angina, and in this case, the word here, its, as, his, and his, have all faded to the background. And that's just a stylistic choice. You can obviously do whatever stylization you prefer. The point being, though, that you can use the output confidence levels, confidence scores at the word level to really inform whether or not you choose to highlight or you choose to drop certain words from the transcript. And that adds that layer of flexibility and transparency for your use. So, you know, I want to talk a little bit about what customers today are doing with Transcribe Medical. Cerner, for instance, is using Transcribe Medical to help enhance clinical documentation workflow efficiency. And what they're aiming to do is to build a next-gen clinical voice scribe that can ambiently listen to patient and clinician conversations and then be able to capture that conversation unintrusively on the fly so that it can be transcribed for later use and augmentation and finally input into EHR systems. Another company called Amgen, which is a big pharma company, uses Amazon Transcribe to unlock key insights for the drug safety use case or pharmacovigilance, as I mentioned earlier. And what they're doing is building a platform that is able to ingest a lot of different types of phone calls from either clinicians directly or to pick up the phone calls between clinicians and patients that report on different types of medicines and the associated side effects that come with certain medicines. And being able to collate all these calls and analyze them, transcribe them first, and then analyze them for the relationships of medicines and side effects is really critical because it allows Amgen to do this en masse and to do it very quickly and efficiently. And if you're Amgen or a big pharma company and your goal is to detect these patterns, you really need to be able to do this with a vast amount of data and to be able to do this across a lot of phone calls. So pattern detection really comes into play when you have a vast amount of data, right? And Amazon Transcribe Medical is able to help transcribe all those calls into text, again, to provide for that initial leg so that Amazon Comprehend Medical, for instance, or any other NLP service can come in and run the analysis. Soundlines is another customer of ours using Amazon Transcribe Medical to help patients get better care but they're essentially using Transcribe to build speech recognition scribes as well to lift the burden of documentation off the shoulders of physicians and clinicians, right? And to be able to do that would mean that physicians have a better chance and focus on the patient themselves. Frequently what you'll find is that providers themselves also use human scribes, right? But human scribes are often awkward in that they're, standing or sitting right next to you as you're having an intimate conversation with the physician about very, very personal things like medical history, perhaps medical conditions and trauma or diseases and illnesses. And this is why when customers like ours use Transcribe Medical to build new solutions like scribes or ambient scribes or virtual scribes, what have you, we feel very proud that our service is able to enable these solutions to really take the burden off of physicians, allow them to focus, and most importantly, steer clear from existing solutions which may have limitations, such as human scribes, who may make the situation or encounter somewhat awkward. A customer called Suki AI is a startup who's using Transcribe Medical to be able to build a mobile app for physicians so that they can, take it about with them throughout their hectic and busy days, so they can transcribe notes on the fly. In this case, the use case is more geared for physicians doing single speaker dictated notes. And so this is used primarily for after patient encounter transcriptions. You can learn more about Amazon Transcribe Medical, Amazon Transcribe, and Amazon Comprehend Medical at the following URLs. Thank you so much for your time, and we're happy to open up the floor for any Q&A.